Sir.
Good afternoon, Professor. Good afternoon.
Good afternoon, sir. So thank you very much for joining in this meet, sir.
Welcome.
So let us start this session by giving a welcome address.
Good afternoon to one and all present here. On behalf of Ramco Institute of Technology, I would like to express my great pleasure in welcoming all of you for the AICTE-sponsored International Conference on Smart Technologies and Applications ICSTA 2022, supported by Department of Biotechnology, National Bank for Agriculture and Rural Development, and Builders Association of India. I feel glad to welcome Dr. S. Periyanayi, Professor and Head, Department of Electronics and Communication Engineering, Ramco Institute of Technology. I would like to extend my warm welcome to all the conference participants, research scholars, faculty members, and students of Ramco Institute of Technology and other institutions. Just before we get started, I would like to express my gratitude to Chief Guest Dr. D. Sriram Kumar for accepting our invitation. On behalf of Ramco Institute of Technology, I gladly welcome you to this International Conference on Smart Technologies and Applications 2022. We feel very grateful to have you on this great occasion. We welcome you, sir.
Thank you, Ma. Should I start, Professor?
Good afternoon to one and all present here. It's my privilege to introduce the guest of the day, Dr. D. Sriram Kumar. He is working as a professor in the Department of Electronics and Communication Engineering at the National Institute of Technology, Trichy. He completed his PE degree in Electronics and Communication Engineering at Tyagarajar College of Engineering, Madurai in the year 1991. He completed his master's with a distinction in Microwave and Optical Engineering at Alagappa Chettiar College of Engineering and Technology, Karaikudi in the year 1993. He earned his PhD in Microwave Integrated Circuits, Coplanar Waveguide Discontinuities, Periodic Structure Analysis, Antenna Applications at Bharatidasan University, Tiruchirappalli in the year 2009. His specializations are Microwave and Optical Engineering, Antennas and Wave Propagation, and Carbon Nanotube Antennas. For his academic excellence, he underwent TEQIP training at Nanyang Technological University, Singapore in May 2007 on millimeter wave techniques and fabrication under the guidance of Professor Dr. A. Alphonse. He got the Best Researcher Award at NIT Trichy in the year of 2017. He has undertaken projects from MH Hardy worth rupees 7 lakhs and 2 DST projects each worth rupees 20.89 lakhs and rupees 60 lakhs. He wrote a book titled Problems and Solutions in Probability, Random Variables and Random Signal Principles by Faith and Isaac Pebbles, published by McGraw-Hill Education Publications in the year 2012. Under his guidance, 7 students completed their PhD and 8 more are doing their research work. He has published more than 100 papers in international journals and presented more than 50 papers at international and national conferences. He has reviewed around 10 preferred journals like IEEE, SPIE, PIER, and HJEE journals. He is a lifetime member of ISTE, INC, IETE, and senior IEEE member. He is the president of CRY Club at NITT and chartered engineer.
Sir?
Yeah. Can I start, sir?
Yes, sir, you can start. You can share your screen.
Sure. Yeah, before I share my screen, I thought I can give a brief talk for about 5 minutes. Then probably I can go to my topic of interest, and probably I would roughly take 30-35 minutes for my technical talk. I'm audible? Any issue in the voice? Is it okay?
Yes, sir, it is audible, sir.
Audible, okay. Yeah. So thanks for the opportunity given to me. I need to thank Ramco Institute. I need to thank my senior and friend, Dr. Ganesan, who is our principal also. And all the faculty, student community who are present virtually here. Very good afternoon to all of you. I just went through the brochure of your conference. It is quite interesting. I could see many eminent people have spoken to you. Very hard topics were discussed. They have given lectures also to you. It's fine. I believe you are one among the faculty, researchers, students in the today's talk. So I thought I can give a general view about optical wireless communication, which is a part of fiber optic communication. This technique may be new to you because not many people are working in this. So I thought I can share some few thoughts qualitatively. I don't want to touch any mathematical analysis, what we have done so far. You may get bored. Anyway, before that, this conference is a good forum. Like it's a good platform for you to learn something new, being a researcher, student, or a teacher, a researcher, being in industry, or anybody. You need to learn the technologies. The conference is something focusing on smart technologies and applications. Smart technologies are not really smart as of today. You know, we are waiting for really, really smart technologies. Maybe in another 5 years, 10 years, the technologies, whatever we have in mind, whatever technologies we would dream, may become reality. So you are the budding engineers and probably you have the right opportunity to work on a future topic. You are so fortunate since you being in EC domain. I'm sure there are a lot of innovative ideas are put forth, a lot of topics to be worked, researched today. So one such domain is wireless. Likewise, there are many, many domains available. This is one such domain. Wireless is a never-ending domain. Everything is going to be wireless. You may think wireless is a topic of ECE. It's not so. Many people are working in wireless now. Probably you can take any researcher from instrumentation, electrical engineering, computer science, and civil, mechanical, all are looking for this wireless. For example, in computer science, blockchain, you know, a lot of researchers are working, and commonly people are talking about ML, DL, AI for optical antenna applications and so on. So see that you are good in any one software algorithm, which is not available in your curriculum, where your teachers don't teach, faculty don't teach. Learn something new from the available resources. If, for example, NPTEL has plenty of courses. Swayam portal has plenty of courses. Go through them, have something new in your mind, get the certificates, okay? So that definitely you can learn new things. Maybe you can easily get into the industry for a job, I'm sure. So that is the order of the day. So out-of-box thinking, out-of-box learning is very important. My sincere request is, you might be in second, third, final year, fine, but learn something new from the curriculum. Beyond the curriculum, some other topics you have to learn. Okay, wireless, as I was telling you, it is MIMO is looking for very good algorithms. A lot of mathematical skill is required. So keep working on it. So you may be good in 5G, you may be good in 6G, probably you develop something towards that. If you are well enough in ML, Python, probably in any other platform, definitely you can work towards Industry 4.0. You can work towards 6G, IoT, anything. So they are all very potential topics in the job market. So another 5-10 years, definitely you can survive. So job is not going to be a problem for you. So something new you try to learn, rather, reading something available from the book and writing something on the exam and getting good grades, forget it. No, that should not be the case. You must have some interest, right? Some of you might be good in algorithm, coding, writing mathematical equations. See that you hone your interest, right? You sharpen your interest and see that you apply somewhere. The conference talks about applications. Very important. Learning smart technology is not enough, but you should see where it is applied, where you can employ the technology. where is the potential application, whether in communication domain or security, in medical applications and so on. I'm sure your institute will hardly work for NBA, NAC, getting autonomous. I'm not sure whether you are autonomous or not, getting autonomous and so on. For which these are the components required. And I'm sure you must be working on OBE, CDIO, TCE. A lot of experts are there in TCE. Okay, maybe you can join with the TCE. You can do something good towards all these things. Beyond that, NEP, National Education Policy, is coming up in a big way. NEP 2020, right? In India, the experts and educationalists greatly talk about this NEP, right? It is going to be a reality maybe in another couple of years. What is it actually? Many do not know what is NEP. Multiple entry, multiple exit scheme. What does it mean, right? In a 4-year beta curriculum, suppose if a guy enters at the end of the second year, if he wants to leave, if the guy wants to leave, he can leave. At the end of the 4th semester, he need not wait for another 2 years to get the degree. At the end of the second year, he can leave with enough credits. But the thing is, you will not get BE degree, but there is some sort of degree like diploma and so on. Similarly, at the end of the 3rd year, final year, right? So this is multiple entry, multiple exit scheme. And across the barrier, probably you can travel in the sense, you need not read the courses which are only available in EC domain. You can go through the courses available in computer science, even civil, mechanical, mathematics, humanities. Some of you might be interested in financial management, accountancy, and so on, business management. So these are all very potential topics. Industry 4.0 is looking for people who are good in financial management, business accountancy, and so on. IIT Madras has launched plenty of online courses. You need not go there. You can register. For example, recently they have launched data science, BSc data science. It's only purely online course. You join the online course, give the exams, get a certificate, BSc degree from IIT Madras, which is a very, very valuable one. So with that, probably with your BE degree, you can walk to any industry. Your job is not a problem at all. So NEP talks about this. Try to have enough number of courses beyond ECE, right? If your curriculum permits. I think your faculty or management has to talk about it, or they have to think about it. So any course of interest, right? We don't want to stop your interest. See, being in ECE, you may be interested in learning something new in electrical engineering. We will not stop you. Definitely you can go to EEE and sit with the EEE students. You can learn something and get the grade and come back. Likewise in any other department, okay? So the barrier is not there, it is removed. So this is the glimpse of NEP. Okay, so even yesterday I had given a lecture to one of the colleges in Telangana. It was very interesting. I did speak about this NEP and other avenues and all. Being students, see that you are good enough in industry exposure, try to have sort of an internship, industrial training, and try to have plenty of industry lectures, right? Maybe with that, at the end of the 7th semester, if you do some internship and projects, preferably in industries, right? Available in your place or out of your place within Tamil Nadu or outside Tamil Nadu. Definitely, this is going to play a very big role in your job perspective. So that is not going to be an issue at all. So the world is so competitive. So many ages keep coming, right? Jobless is one of the big issues today in India. So you need to compete with them. So unless you equip yourself, it is very difficult for you to survive. So try to learn smart technologies and new things, new platforms, MLDL, AI, IoT. And with that, you move forward. Try to learn the technology which is on the paper now, right? Not in reality. Maybe after 5 years, which technology is going to come? 6G, for example, 6th generation, mobile phones and other things and all, in which you try to work something. You are not asked to develop a full mobile phone, not necessary. You have few algorithm, right? A small algorithmic probably you can develop, right? You just see the difference between 5G and 6G, something. See, in 5G, seamless connection is possible, right? Continuously, you can get the connection wherever you are. Probably continuously you will get your connections. You are connected continuously, and remotely you can diagnose the problem. If there is any issue in your connectivity, one need not come there physically. Remotely, one can dine here sitting at one place, right? Likewise, some of the features probably you can explore in 6G also. So these are some points I just wanted to share with you today. So with that, I'll share my PPT and probably I'll go for 30 minutes. If you have any questions, you can ask me at the end of the lecture. Now, as I promised, I will not touch upon any equations, any complicated mathematical modeling, because this is a pure research topic. I don't teach this to UG. I teach this for MTech and PhD scholars. So with this, I just switch off my video and show my PPT. Is my PPT visible?
Yes, sir, it is visible, sir.
Yeah. Thank you. So this is roughly about 40 slide presentation. Optical wireless communication, challenges and opportunities. This is also one of the smart technologies, right? This is no way disconnected from smart technologies. It is more related to 5G, 6G. It is more related to IoT, right? Medical applications, fiber optic communications. And I was talking about DLML and all. You can work in any of these, the catchy topics, even in this optical wireless communication also. So, as I was introduced, I am Professor Sriram Kumar, professor at Department of EC at NIT Trichy. I'm here since 1997. Almost I'm closer to 25 years here. And I'm also heading a Siemens Center of Excellence here in manufacturing. So I just make a couple of lines about the Siemens Center of Excellence because you are not aware of it. This Center of Excellence is so fantastic in our campus because this is first of kind in India. We have invested roughly about 220 crores to establish this center. This is a 4-year-old baby in our campus and, a lot of facilities we have. If you're interested, probably you can work in IoT, 5G and so on. Anyway, the details are already posted in our website under Siemens Center of Excellence. And you can go through them. We are also offering a lot of online courses. And if your institute or institutes willing to sign an MOU with this, you can write to me. We will help you to sign an MOU with this. Maybe after that, your faculty or a principal or your management, anybody can come to our center. They can have a feel of the facilities what we have. And in turn, you can call your students after some time. And you can join our courses online, offline, or whatever it is, and get the certificate from this. And probably with this also, you can straight away go to the industry for your project or training or placement. So we've been offering this service for last 4 to 5 years. And so far, we have trained roughly about 5,000 plus students, comprising PhD, MTech, and BTech students. We do a lot of service. We don't charge much, don't worry. Very, very nominal charges we do because we do kind of service to the society, to the country. After us, 3-4 NIT started the center because we were the first to start the center in India in the year 2018. Okay, so other details are already available on the website. You please go through that. I don't have much time to share the details now. Okay, so with this, let me go for the outline of this talk, introduction, and what is FSO. FSO stands for Free Space Optics. Optical wireless communication, free space optics, both are synonymous. Then why we have to go for FSO? What is the need to go for free space optics? Basics of free space optics, we'll see. Some of the challenges, potential applications. What are the career opportunities and conclusion at the end of my talk. As I said, free space optics, optical wireless communication, both are same. Free space optics in the sense, you transmit light in free space. In the conventional fiber optic communication, all of us know that, light is getting transmitted in a fiber, optical fiber. Could be a glass fiber or plastic fiber, for which we need a core and cladding. So with this cable, we can transmit light from one end to the other end to a very longer span. Distance is not a matter. You can transmit light to any number of distance. It's not a problem at all. So what are the potential challenges? Some applications we'll see. We'll highlight some of the applications also. In fact, this is one of my scholars' PhD work. right? So I and Dr. Jairani, who is also heading one of the departments in Trichy College, local college in Trichy. She has done enormous. She is my 12th PhD scholar. In fact, 13 PhD scholars have been gone out, have been produced by me since 2009. So she is my 11th scholar. She has done enormous work on this optical wireless communication. What is this particular slide talk about? September 11, 2001, New York. Some of you or most of you would have come across the incident, the Twin Tower attack. You might be remembering this. One second. Yeah. This Twin Tower building, you might be remembering, right? So terrorists all the way tried to blow up these two towers, and in no time, these two towers got reduced to rubbles. It was not available. It was not seen for after a couple of minutes or so. So this was a Twin Tower incident happened in 2001, September 11. So the same image at a distant point, like a huge smoke came out, and after some time it totally got collapsed. So as you know, it is roughly about 125-story building in US, and this is heart of US. Both the buildings, the Twin Tower building is heart of US, because the entire communication and the stock market was totally functioning in this building. That's why this was targeted by the terrorists. And many people lost their lives, and communication was totally destroyed. I remember some 3,500 people passed away, expired, or died during this incident. And the building got fully damaged and full of debris, and they took days and months together to clear the debris with the help of smart technologies again, right? They have used LIDAR technology, LIDA, or light detection and ranging. With the help of LIDAR, the researchers were able to find the volume of the debris and how much time required to clear the debris and so on. So accurately, they were able to do all those things, clearing and other things and all. So that is the story behind this slide. Yeah. During that incident, everything was destroyed, including normal life. So this is the Wall Street stock market was closed because the communication was totally destroyed. You just imagine, it is roughly about 125-story building and fully connected with the networks. And because of this tragic incident, the network was totally broken, right? Nothing was there actually. No communication was, it was totally dead. Communication was totally dead. So it was closed for some time. Now, closing a stock market is not that easy. Even if you close it for half an hour, 1 hour, there is going to be a big gap, right? Heavy loss, huge loss. In India, it is going to be a big issue. So what happened was, as soon as the building got collapsed, what researchers did is, like similar to these two, A and B, this is the free space setup. Like this, you can see the left side laser, right? So this laser was initially set up, and this was able to give a light beam like this, laser light, no fiber, it is in free space. So this laser light would always strike the next target or the building or whatever it is, right? So this way you can establish the communication in no time, okay? Hardly it will take some 2-3 hours, not more than that, to completely establish the communication between two structures or buildings. So the FSO communication, free space optics communication between Merrill Lynch brokerage and Wall Street in New York also got affected by the terrorist attack. So the entire fiber optic link within the building, lot many fiber optic cables were running, all got destroyed, right? So maybe with the help of this concept of free space optics, it was partially restored. Immediate communication was restored between the source and destination, or it could be between two different points. So coming to this slide, using free space optical link, the concept is not new to us. Somewhere you see it has been using. In Sydney, Australia, the TV signals of the Olympic Games were broadcasted. okay, by TerraBeam Networks. This is a fiber-less broadband IP service provider. So it happened some time back, right? A couple of years back it happened. And until now, worldwide broadcast network have used fiber optics or microwave systems to transmit TV signals. So far, we had been using only fiber optics and microwave. This fiber optic, the free space optics also could be used as an alternative. For example, Lucent Technologies, started broadcasting channels between International Broadcast Center and Sydney Olympic Center. They used this free space optical data link, and a couple of case studies in UK, somewhere it was using, and the TerraBeam was a big player as far as the FSO is concerned. Don Hasse was the president and CEO of the TerraBeam, right? He was giving a trial. He was experimenting it in a big way. So it was not a dream, establishing a fiber optic communication that is in free space is not a dream. It is a reality now, right? So these are the ways by which you can establish the FSO. So this is a setup available in Malaysia, right? At one point, probably you can have this transmitter setup. So somewhere, this is in British, again in British, right? So this is quite interesting to see. Even in the shutter, probably you can have this FSO setup, right? The shop shutters probably you can fix. Okay, so it won't take much of time. RD5 terminals probably you can take and you can fix it. So this will be able to give light, laser light signal. So this is one setup available in London, and this is again in Malaysia. So why I'm showing all these figures is, establishing this setup will not take much time. Maybe within half a day, one day, you can, have a complete link based on this FSO. History of free space. As I said, free space concept is not new to us. It was there. This is a China war. Great Wall of China. Great Wall of China, which is even visible from moon, as researchers say. Right? Those days, from this wall, the troops, Chinese troops, the PLA troops, would be, showing some light. I'm talking about some 100 years back, right? So they used to lit fire, and depending on the number of fires, probably the people in the other side of the wall, Great Wall, will know what is the size of the enemy approaching the wall. If the size is so big, then there will be too many fires. So that was the concept or the technology used those days in Great Wall of China. This was firstly used by Greeks in 8th century. Just imagine, 8th century itself, the concept was used. Accordingly, the light source, fire is used as a light source. The atmosphere is the transmission medium, I as a receiver. Graham Bell done some experiments in the 19th century. They are called photophone experiments. Most of us know what is photophone. This is one of the rare photos. Alexander Graham Bell, who is sitting here, he was testing the photophone. It was not a successful technology, but he kept on trying, right? So he converted voice sounds into the telephone signals, and he could transmit them between receivers through free space along the beam up. So the distance he tried was only 600 feet, not more than that. But this was not a successful technology. It didn't come to reality. So some history points. So this has been used for thousands of years in various forms. As I told you, it is not a new, it is quite old technology, but it was using in different forms. Romans used, Graham Bell created photophone. German troops used heliograph telegraphy transmitter to send optical Morse signals for distance up to 4 kilometers. And 1960 lasers invented, right? After that, FSO coming to reality in a big way. Because lasers are quite handy. Lasers play a big role in plenty of applications today, right? Sometimes lasers can become doctors also. In medical applications, lasers are so helpful to the doctors. Many major surgeries are getting avoided because of the invention of the laser, right? With the green laser, probably whatever health issue you have in your body, probably it can be cured off. So without any major surgery, probably you can go with the lasers, right? With the lasers, probably you can check your eye power, correct your eye power, right? the brain can be tested, heart can be tested, and suppose your nose is not looking beautiful or your mouth is not looking beautiful, probably with the help of the lasers you can correct your nose and mouth, right? And how about eyes? Yes. And even if eyeball is black, Indians generally have black eyeballs. Suppose if I want to have green eyeball or a blue eyeball, is it possible? Yes. With the help of lasers, probably you can convert, right? So this technology is available in US, not in India. You need not try this, right? So this technology is not available in India. Sometimes lasers also will tell you how long you will live, right? It becomes an astrologer. By assessing the cell nature in your hand, lasers will tell you how long you will live. Okay, the lifetime also can be predicted with the help of the laser. And gallium arsenide LED and first laser link to handle NEC Japan started some work and did some work in FSO in the year 1970 itself. So light becomes an intelligent language. Okay, through light you can transmit whatever you want. Okay, such a fantastic signal is a light. So what is going to be interesting in this? I think you will come to know. I need not reply, and you will come to know. So some of the emerging technology trends are IoT with optical wireless. I told you, Internet of Things playing a big role in communication, medical, and so on. So if you club IoT with optical wireless, I think you are marching towards Industry 4.0, which is one of the very smart technologies. What is that Industry 4.0? Many of us may not know. Everything is going to be completely digital, right? So digital transaction, right? Everything is going to be in digital domain. So that is towards IoT Industry 4.0. So that is also coming up in a big way. A lot of people are working on it. And we have BHL Trichy nearby. So BHL Trichy nearby is helping us in a big way to teach Industry 4.0 to our students. So we have a good tie-up with them also. So today IoT covering any communication between devices, and not only in communication, it is also used in flexible manufacturing, augmented reality, AR, VR, you would have come across. Autonomous cars, another big research is going on in autonomous cars. All this IoT, 5G, 6G, all are playing big role in this. AI, right? So that's why I told you, if you are good enough in these areas, I think your problem is solved. You need not have a fear of getting a job. So future IoT will need mobile communication, right? So IoT, what I mean to say is IoT is to be integrated with the 5G and 6G in future. IIT Madras and Samir Chennai do a lot of work in this, right? So the light wave communication can use, another advantage is for this FSO, you need not go for licensing, right? Unlicensed optical spectrum can be used. You need not wait for a long time. Next. So the main challenge to approach future IoT is to develop optical wireless communication further into the mass market, serving a greater variety of use of case than today. It is one of the potential domain to work with. Anyway, I just keep this. I'll focus on some of the figures. So when you talk about wireless, it is going to be completely optical, right? With the complete optical domain, you can talk about wireless today. So steering of beams, bending of beams, right? For IoT devices applications is not a problem. Yeah, this is one old slide, right? According to the Internet Society, over 80% of the world will be connected to the Internet by 2020. It was predicted long back, but we achieved even before that, right? 80% was achieved even before that. Now that it is almost 100%. They were predicting data rate for 3G, 4G, 5G and all. But now we are talking about 5G and 6G. 6G research is already on, right? A year back it was started at Samir Chennai and few IITs started putting their hand. So by 2030, probably we can see all our 6G products getting rolled out, right? Maybe in another few years, before the end of this year, probably we can see most of the products running out from industries towards 5G. So that is going to happen. So this optical wireless communication transmission is through the deployment of optical frequencies like infrared, visible light, and ultra. This is one of the famous electromagnetic spectrum, right? This one. Yes, one of the electromagnetic spectrums wherein which we use this optical wireless communication in terahertz frequency, right? Terahertz is 10 power 12 hertz, 10 power 12, right? We don't use the conventional RF or other frequency spectrums. So these are some of the pics showing how the optical wireless communication concept was evolved, right? The big fire, got lit in something like a chimney like this, and something like, transmitting Morse code from a reflector used by those days kings and all, right? So this is one such research, and similarly, focusing light in one particular direction, like what is seen in a lighthouse in the shores. Perhaps if we go to Pondicherry or Mahabalipuram or Chennai, probably you can see this tower. Yeah. This is the block schematic of optical wireless communication comprising transmitter, receiver, and the source and detector, and so on. These are some of the LEDs which can be, or the sources which can be used in reality, right? So this is basically a smart lamp, right? Not the conventional LED lamp. Smart lamp in the sense what? This will glow light, this will emit light. In addition to that, with the help of this light, you can access all your electronic gadgets. See, for example, if you are sitting somewhere, have your laptop or mobile phone, if you don't get the signal, these LEDs will help you to get you the signal and your devices are getting connected. So these are some of the real-time sources available in the market today, right? Another thing is, as far as LED is concerned, it is so rugged, we will not much worry about it. But laser eye safety regulations are must actually, because if you pass laser beam continuously to your eye, maybe after a few seconds, the eyes will get damaged. Sometimes it is going to be a permanent damage also. So this is some of the advantages. Large bandwidth capacity. So another point is actually bandwidth is going to be enormous. No regulated spectrum, unregulated spectrum is possible, will do. And security is not a problem at all. Though it is transmitting in free space, if I try to tap the signal from free space, I will not get anything. I will not understand anything. Okay, so inherent security is also there. And this can be safely used in RF restricted areas like aeroplane, spacecraft industry, and so on. In airplanes, even when you fly, see, for example, I'm flying from Trichy to US, and I need to sit in the aircraft for about 10-20 hours. So continuously, I can use my laptop or mobile phone with the help of this technology. So this is a reality now. Many airlines have started, Lufthansa and other abroad flights started using this technology. India, it is in the initial stage. So these are some of the applications where we can talk about this FOC, flexible manufacturing in industries, right? This IoT in turn, this optical wireless communication will play a big role. And this is what I was telling you, right? All these lights can give data, right? These are nothing but the data emitters, data sources. So with the help of that, all your gadgets in the table can be activated. Okay, so this is within the flight. You can see in the mass transportation. Security is another big thing to be addressed. So it is basically a secured wireless because we take in the form of light. Okay, then optical backhaul for small cells in 5G, right? It is slowly integrating with the 5G also. So depending on the internet application, some of the supportive technologies are ultra short range, and long range. Ultra short range is in the sense within the chip, probably within the PCB or within the chips, probably you can transmit light, right? You can transmit data using FSO communication. This is slightly bigger, like in the LAN, probably you can use, this something like a table lamp. With the help of this lamp, you can access your laptop or mobile or any device. So this technology was invented in UK, right? In the order of kilometer between buildings, probably you can use, and more than 10 kilometers also you can use this technology. So in biomedical applications, probably it plays a big role in body area network, physical and biochemical information about the individual, right? Doctors are wanting this actually, right? Once this technology reaches doctors, I think doctors will be very happy to receive such things and go for a quick patient monitoring. So another interesting application is PAN, passive personal area network, right? Last mile connectivity for interconnecting a device center around an individual person's workspace. So optical wireless PAN also getting spreaded into different applications. Okay, so some of the startups, just leave this. I talked about this Li-Fi light fidelity, right? So this is the LED bulb. This is supposed to give data to the users, right? So it will glow as well as with the help of this LED bulb. Probably you can access your devices also. That is the concept of VLC, visible light communication, or you also call it as Li-Fi light fidelity. So there are plenty of startup companies available on VLC on in UK, US, and so on. Yes. We can also use this optical wireless concept in underwater, right? In sea, probably to see the test bed. A couple of days back, I saw in Hindu, somewhere in one country near the sea, probably a ship which got sunk 100 years before, right? 100 years before was tracked, right? So this was done with the help of this free space technology or free space optics. So in underwater also, probably you can use this technique. In vehicle-to-vehicle communication, right? Suppose if you get stuck in traffic, with the help of this light, you can access your gadget, right? This is a smart lamp, but it is a data source also, right? With the help of this, you can continuously access your devices, a lab or whatever it is within the car. So vehicle-to-vehicle communication, vehicle-to-infrastructure, a lot of work is on in this topic. And drones, right? Aircraft-to-aircraft, ground, satellite. So these are some of the applications. Okay. Drones is another big area in which a lot of people are working. We have also got a project in drones, and ISRO, DRDO want plenty of technologies in the plenty of advanced technologies in the drones. Why free space optics, FSO and radio frequency? This shows the clear difference between FSO and RF spectrum. The spectrum is scarce and low bandwidth. It is regulated. It suffers from multipath fading, right? Large components required for RF. Whereas in the FSO, this channel can offer terabits of information, right? In terms of TPPS, probably you can talk about the data rate. And the spectrum is large. No license is required for FSO. Small components. With small components, you can construct a bench or set up in FSO. Secure communication is possible, right? And transmission range is also limited by weather condition. Thing is, using this FSO concept, you can't transmit signal to a very long distance. For about 5 to 10 kilometers, probably you can check. We have already tested for 8 to 10 kilometers. And beyond that, you can simulate, but practical setup is quite difficult. But a couple of institutes are working on this FSO. Some of you would have heard about DIAT, Defense Institute of Advanced Technologies in Pune, DEAT. I have my scholar there, and he's keenly working in this DIAT project. And those days, probably you would have seen the fiber optic cables are getting laid on the roadside. It takes a lot of time. For about a month, it will require to lay even 50 kilometer fiber. But FSO doesn't need any digging. No permission is required. No fees, right? Installation could be faster. If, for example, 2-3 years back near Karaikal, Nagapattinam, there was a tsunami-like scenario took place. There, the entire communication was totally destroyed for about a week or so. Then this FSO was quite handy. People all the way went there, and they were able to give this technology set up within half an hour or so, right? It is such a wonderful technology, FSO. Installation is very fast. So why we have to still use FSO? This is using laser light as a carrier. You can talk about full duplex, full speed AND or NOR gate or whatever it is. Ethernet, distance up to 10 kilometer possible. It is not 5 now, 10 kilometer possible. Installation is easy, almost no maintenance is required. So this is the fantastic slide which appears in this book, Gaussam Law from Northumbria University, UK. One side, WAN, the fiber-based WANs require heavy data rate. The other side, LANs in building also require 100 megabits per second. But matching this with this is a big bottleneck, right? The connections in between are typically a lot slower. So we need to address, this is a great research problem here, right? So this has to be matched with this LAN requirement. So here the actual research is lying. So this is greatly addressed by this guy, right? In this book, Optical Wireless Communication System by Gaussam Law. This is one of the fantastic books Because he has written a lot of MATLAB codes for the channel modeling and so on. If you're interested, probably you can read this book. I have a copy. It is very interesting to read this particular book. So this is the FSO block diagram, right? I think it is self-explanatory. Where we use LED, and this is the set of lenses in between free space and the photodetector. And with the help of the signal processing unit, probably you get back the actual data what was transmitted. So if you closely look at it, 1010 is transmitted, 1010 is received. Suppose if 1010 and here it is 1011, there is somewhere error, right? So that can be detected with the help of error pattern or eye diagram. Yes. Yeah, the same setup. I just skip. Yes. So some of the effects which are unavoidable are atmospheric attenuation and atmospheric turbulence. Right? These are unavoidable because naturally they are there in the free space. Like we talk in terms of absorption, scattering, laser beam wandering. Like a laser beam is emitted in free space. You can't expect the same cross section throughout the length of the travel. So the beam cross section keeps varying. So beam wandering is one of the unavoidable phenomena in FSO, and scintillation, right? So there's another big issue. So these are to be addressed in FSO problems. So what are the potential challenges in FSO? Misalignment error, geometric loss, background noise, eye safety, attenuation loss, and so on. There are very, very potential challenges. It is quite a budding topic, not a full-fledged topic. Still a lot of research is on, many things to be addressed. So two of my scholars have done PhD in this FSO, and they have done a very successful work, generated a lot of papers also. I think last couple of slides. So what are the challenges in FSO? Yeah, between the buildings, we need to consider the obstructions, scintillation, the fog, and other things and all. You may think that all the buildings are quite stable. It is not so. The high-rise buildings, for example, 15, 20-story building, will not be standing stable all the time, right? So during heavy winter, heavy wind blow, the building will be shaking, right? For about 5 to 10 millimeter, the building will be just oscillating, right? It is by nature. You can't see it by naked eye, but it is there always, right? So accordingly, the building structure has to be designed and all. It's what people are doing. So because of that, there is going to be some lacuna, something to be addressed in FSO. So that's why I said all these things have to be addressed: building motion and obstructions, scintillation effect, fog, all those things to be considered in the alignment in the FSO analysis. So all is under a mathematical component. So how this can be achieved? We need to focus on 1550 nanometer wavelength. Though there are plenty of operating wavelengths available, 1550 would be very promising. And we need to talk about WDM, wavelength division multiplexing. WDM is nothing but optical equivalent of FDM, frequency division multiplexing. A lot of work is on in WDM. Like all our telephone networks are completely based on this WDM. In India, 90% of the communication networks are completely based on this WDM. That we call it as DWDM, dense wavelength division multiplexing. This is one such modulation format, FSO, POLSK, polarized shift key. With the help of this format also, probably you can analyze the FSO signal, and mathematically you can calculate the bit rate, and you can simulate with the help of few softwares. Like there is a software called RSoft. Lumeric is one software. COMSOL is another software. With the help of them, probably you can simulate and see the results. And you can use it as a relay. Suppose if you want to go for long distance enhancement, like communication, you can use this setup as a relay also. You know what is relay. So some of the channel models are log normal, gamma, negative exponential. I just keep this because each is behind a complete mathematical model. You can analyze all these three channels completely by mathematics, writing mathematical equations. So the conclusion is light technology is a never-ending technology. It is going to be trending towards 5G and 6G. Right? Even at the end of the 6G by 2030, this technology is going to be a very big boon. From 2015, the year for International Year of Light, the light technology is playing a very big role. So maybe in another couple of years, light is going to completely dominate the world. So alternative solution to RF technology and mobile networks are to be redefined, restructured for this. The work is on by the network operators and providers. And the world is moving towards light technology combined with other technologies also. So this is the conclusion from my talk. These are some of my references. And a few references are from my scholars. You can see Prabhu, right? He's one of the good scholars. He generated a paper along with the IISc professor, Dr. Srinivas. Again, Prabhu. And yes. And this guy is currently a faculty at NIT, Surathkal. Thank you. That is the end of my talk. Any questions?
Participants, any questions?
It seems all have enjoyed my talk. Huh? Okay.
Okay, participants, kindly fill the feedback. So that is posted in the chat box. So thank you, sir. Thank you for your valuable presentation.
Thank you. Thank you.
So we came to understand the concept of optical wireless communication through your lecture. So as a continuation of this session, so we can follow the paper presentation also, sir.
Sure, sure.
Good afternoon to all. Now we start the session 2, the domain communication system. And the chairperson is external academician Dr. D. Sriram Kumar, Professor, Department of Electronics and Communication Engineering, National Institute of Technology, Tiruchirappalli. And another chairperson from internal faculty, Dr. S. Vairaprakash, Associate Professor of ECE at Ramco Institute of Technology, Rajapalayam. So shall we start the session, sir? Presentation.
Yes, ma'am, we can start.
Yes, sir. And the first presentation, the paper ID 118. The title of the paper, Equipment Configuration and Optimization of AGV Unmanned Warehouse. The authors, Ms. K. Dharani, Ms. P. Haripriya,